Hello students, welcome to Mint Books teleclasses for class 10. My name is Nitesh and I will be teaching you mathematics. The topic for today's mathematics teleclass is arithmetic progression. Now let's begin. Any series of numbers that are related to each other by a certain rule is called a progression. An arithmetic progression is a series of numbers where each term is obtained by adding a fixed number to the preceding term except the first term. If the number of terms in the series are limited, then it is called as a finite arithmetic progression, and if the number of terms in the series go up to infinity, then we call it as infinite arithmetic progression. Now let us discuss what are the various properties of an arithmetic progression. So far we know that in an arithmetic progression, we will have some terms which will differ by each other with a small difference which will be constant for any two successive terms. Now the difference between the successive terms of an arithmetic progression, it is called as common difference. This common difference is denoted by the small letter d. Any arithmetic progression will start from a term and it may end up a term or it may go up to infinity. The first term for any arithmetic progression is denoted by the small letter a. So if we consider the first term of any AP to be a and the common difference be d, then we can write down the first term as a, second term as a plus d, the third term as a plus 2d, the fourth term as a plus 3d, and so on and so forth. So we can write down an AP as a plus d, a plus 2d, a plus 3d, and so on. Now you can observe here that the second term of the AP is a plus d, the third term of the AP is a plus 2d. So we can write down the general term of an AP, the nth term, as a plus n minus 1 into d. Now the nth term of an AP is denoted by the symbol an or tn. Now this relationship between the successive terms of an AP and the formula for finding out the nth term of an AP can be used in different types of questions. Let us see an example. This is example number 1 in the chapter Arithmetic Progression. Find the 25th term of the AP minus 5 by 2, 0, 5 by 2. Now it's already been told to us in this question that the numbers are in AP. So just by looking at the series, we can know what is the first term. You can observe that the first term here is minus 5. So we'll quickly write down a is equal to minus 5. Now our next job is to find out the common difference of the AP. Now as we know, common difference for any arithmetic progression is equal to the difference between consecutive terms. Now the terms here are minus 5 by 2, 0 and 5 by 2. You can take any two consecutive terms and find the difference between them, and that will become our common difference for entire arithmetic progression. Now for our convenience, we will take 0 and 5 by 2 because it's very easy to subtract and there are very less chances of error. So our common difference now d becomes equal to 5 by 2 minus 0, which is equal to 5 by 2. Now we have to find out the 25th term. So we will simply write down the formula for finding nth term of an AP. The formula for nth term of an AP gives us an is equal to a plus n minus 1 into d. Now for the given question, the value of n is equal to 25. The value of a we have found out to be equal to minus 5 and the value of d we have calculated as 5 by 2. So we can substitute those values and find out what is a25. That will become equal to a plus 25 minus 1 into d, which is equal to minus 5 plus 24 into 5 by 2, which evaluates to 55. So by using the formula for nth term of an AP, we have found out that the 25th term of the AP which is given to us is 55. Now if you notice here that when we were given the question, the first thing that we did was found out what is the first term and what is the common difference of the AP. Now for any given arithmetic progression, the first term and the common difference are the two quantities which completely characterize an arithmetic progression. So for any given question, the first term that you will be looking for is what is the value of A and what is the value of D. The value of A and D might be given to you in term of the series, just as we saw in this particular question, or the value of A and D might be given to you indirectly. For example, if in a question we are being told that the second and the third term of an AP are so and so, then if we need to find out the common difference, we just need to subtract the third term and the second term. To find out the first term, we have to subtract the common difference from the second term. So there can be multiple ways of finding out what is the first term of an arithmetic progression and what is the common difference in the arithmetic progression. But for any question, those are the two fundamental quantities that we will be looking for. Let's take another example. This is example number 2 in the chapter Arithmetic Progression. If k, 2k minus 1 and 2k plus 1 are the consecutive terms of an arithmetic progression, find the value of k. Now you should note here that k, 2k minus 1 and 2k plus 1 are the consecutive terms of an arithmetic progression, but they are not necessarily the first three terms. If they were first three terms, then k would become the first term for our AP. So in this case, it has not been given whether or not these are the first three terms, or whether k, 2k minus 1 and 2k plus 1 occur some place in the middle of our arithmetic progression. So we need not worry about that. But the one thing which we can see from this is that k, 2k minus 1 and 2k plus 1 are the consecutive terms. So by the property of an arithmetic progression, the difference between consecutive terms should remain same for any arithmetic progression. So we can write down 2k plus 1 minus 2k minus 1 is equal to 2k minus 1 minus k. Now on simplification, this will give us the equation k minus 1, which is equal to 2k plus 1 minus 2k plus 1, which gives us k minus 1 is equal to 2 or k is equal to 3. So by using a simple property of arithmetic progression, that the difference between any two consecutive terms remains the same, we were able to find out the value of k for this particular question. Now we saw a formula for finding out the nth term of an AP. Now another way in which that formula can be used is in the form of following question. This is example number 3 in the chapter Arithmetic Progression. Which term of the AP 100, 90, 80 and so on is 0? Now in this question it has been given that the first term is 100, the common difference you can calculate. You are being told that 0 is a term which belongs to this AP, but we are not told what is the position of 0 in this series. So we have to find out that in the series 100, 90, 80, 70, 60 and so on, at what position will 0 occur? So as our first step, we will write down the values of first term and common difference. The first term will be A equal to 100. The common difference will be the difference between any two consecutive terms. We will take 90 minus 100. So we will get D is equal to minus 10. Now we can see from this arithmetic progression that the numbers are decreasing as we go further in the series. So at some point we will get 0 as term of the AP. But we don't know at what position we will get that. Now let's just assume that we get 0 at the nth position. Then we can write down an is equal to 0. But we have a formula for the nth term of any arithmetic progression. The formula states an is equal to a plus n minus 1 into d. We know what is a, we know what is d, but we don't know what is n, and this is precisely what we need to find out. So we can write down an is equal to 0. This equation will give us a plus n minus 1 into d is equal to 0. Now substituting the values for a and d, we will get 100 plus n minus 1 into minus 10 is equal to 0. On simplification, we will get 100 minus 10n plus 10 is equal to 0, which is a linear equation. Now this linear equation is very easy to simplify. We can simplify the equation and we can get the value of n as 110 divided by 10, which is equal to 11. So the 11th term of this AP is 0. Now there is another point which should be noted here. It is not necessary that 0 will be a term of any AP that has numbers in the decreasing fashion. Let's say I take an arithmetic progression which starts from 3. It has a common difference of 2. So first term is 3, next term is 3 minus 2 which is equal to 1. The third term is 1 minus 2 which is equal to minus 1. So you can see that the arithmetic progression goes like 3, 1, minus 1. Even though the terms are decreasing in magnitude, 0 does not occur as a part of this arithmetic progression. We will see a question later on which will deal with this type of concepts. Now the next question which we are going to discuss will move away from finding the term or position of a term, and we will talk about the arithmetic progression in terms of relationship between its distinct terms. This is example number 4 in the chapter Arithmetic Progression. In a certain arithmetic progression, the 32nd term is twice the 12th term. Prove that 70th term is twice the 31st term. Now once you get a question like this, don't panic by looking at the big numbers like 70, 32, 31 and all those things. Keep in mind that this question pertains to arithmetic progression, and if you know the properties of arithmetic progression properly, then nothing is going to stop you from solving this question properly. Now in this question, one of the relationships is given and we need to prove another one. Now we do not know the first term and the common difference for this arithmetic progression, so we will assume them to be A and D. So first we will write down, let the first term of this arithmetic progression be A and the common difference be D. So we can write 32nd term, that is A32, is equal to A plus 32 minus 1 into D, which gives us A plus 31D. Similarly, we can write down 12th term as A plus 12 minus 1 into D, which gives us A plus 11D. Now according to the question, the 32nd term is twice the 12th term. So we can write down an equation, A plus 31D is equal to twice of A plus 11D. Now we can simplify this and we will get a relationship between A and D. On simplification, you will get A is equal to 9D. Now this relationship has been obtained by the condition already given in the question. We will use this to prove another condition which is there in the question for us to prove. Now the other two terms between which we have to prove a relationship are 70th term and the 31st term. Let's not waste time and go ahead and find out what those terms are. We can write down 70th term is equal to A plus 69D. Now we know A is equal to 9D. Let's substitute the value of A is equal to 9D in this equation. We will get 70th term is equal to A plus 69D is equal to 9 plus 69D, which is equal to 78D. And 31st term is equal to A plus 30D. We can write down 31st term as 9D plus 30D, which is equal to 39D. Now you can see 70th term we have obtained as 78D and 31st term we have obtained as 39D. Now we know 78 is equal to 39 into 2. So we can say that 70th term is twice the 31st term. So by assuming the first term and the common difference to be A and D and writing down the condition which is already given in the question, we were able to prove a second condition which was asked for us to prove. Now next we will see some other concepts related to an arithmetic progression. Now for a finite arithmetic progression, we will have a first term and a last term. The last term for any AP will be denoted as letter L. If there are n terms in the AP, then the value of last term L will become equal to A plus n minus 1 into D. Now this is another relationship which is used at multiple places to solve questions related to arithmetic progressions. Let's take an example. This is example number 5 in the chapter Arithmetic Progression. How many 3-digit numbers are divisible by 7? Now we have to find out what are the total number of 3-digit numbers that are divisible by 7. Now the 3-digit numbers divisible by 7 are all written in sequence with the smallest at the beginning and the largest at the end, then you can see it very easily that the two consecutive numbers will differ by 7. So all the 3-digit numbers which are divisible by 7 can be written as part of an arithmetic progression, with the first term being the smallest 3-digit number which is divisible by 7. So we have an arithmetic progression where we know what is the property of all the numbers, but we still need to find out what is the first term of this arithmetic progression. So to do that, we have to find out what is the smallest 3-digit number that is divisible by 7. Now the smallest number that is divisible by 7 is 100, and you can easily find out the smallest 3-digit number which is divisible by 7 is 105. We also know that the largest 3-digit number is 999, and you can find that the last 3-digit number, the largest 3-digit number which is divisible by 7 is 994. So if I write down all the numbers which are 3 digits and are divisible by 7, then we will get an arithmetic progression where the first term will be 105 and the last term will be 994. Now as per the result that we had derived earlier, that last term is equal to a plus n minus 1 into d, we can write down 994 is equal to 105 plus n minus 1 into 7, because for this arithmetic progression 994 is the last term, 105 is the first term, 7 is the common difference, and we have assumed that there are total of n terms in this arithmetic progression. Now if you solve this linear equation, you will get the value of n as 128. So the last term in this AP is the 128th term, and this arithmetic progression represents the 3-digit numbers divisible by 7. So we can easily say that there are total number of 128 3-digit numbers that are divisible by 7. Now we will see another concept which is related to sum of n terms of an AP. Now the terms of an arithmetic progression we know they differ by a constant difference. So the sum of all the terms of an AP would also be an interesting thing to see. Now let's see what happens if we are trying to find out the sum of n terms of an AP. Let us consider an arithmetic progression up to its n terms. If the first term is a and the common difference is d, then it can be written as a plus d, a plus 2d, a plus 3d up till a plus n minus 1 into d. Now adding all these terms, we will get the sum to n terms. The sum to n terms of an arithmetic progression is denoted by Sn. So we can write down Sn is equal to a plus d plus a plus 2d plus a plus 3d up till a plus n minus 1 into d. Now if I write the same equation in the reverse order, we will get Sn is equal to a plus n minus 1d plus a plus n minus 2d up till a plus d plus a. Now if we add the two together, on the left hand side we have Sn, so we will get 2Sn is equal to, if we add the corresponding a's and leave n minus 1d term as the same, we will get twice of Sn is equal to 2a plus n minus 1d plus 2a plus 3 plus n minus 2 into d plus up till 2a plus n minus 1 into d. This equation will simplify as 2Sn is equal to n multiplied by 2a plus n minus 1 into d. So we can write down Sn is equal to n by 2 into 2a plus n minus 1 into d. Now this is the formula for sum to n terms of an AP in terms of first term, common difference and the number of terms. Now you can see 2a plus n minus 1 into d can also be written as a plus n minus 1 into d. Now a plus n minus 1 into d is the last term L. So we have another formula for sum to n terms as Sn is equal to n by 2 whole multiplied by a plus n. Let us take an example and see how this result is used in solving questions. This is example number 6 in the chapter Arithmetic Progression. The first and last terms of an AP are 5 and 45. If the sum of all its terms is 400, find the common difference. Now it has been given to us that a is equal to 5 and L is equal to 45. We are also told that Sn is equal to 400 for n terms. Now if there are a total number of n terms in the AP, we already know we can write down Sn is equal to n by 2 into a plus L. Substituting the values for Sn, a and L, we will get 400 is equal to n by 2 into 5 plus 45. We can simplify this and we can get n is equal to 400 into 2 divided by 50, which is equal to 16. So we can say for sure that there are total number of 16 terms in this arithmetic progression. Now the last term for this arithmetic progression, it can be written as a plus n minus 1 into d, which is already been given to us as 45. So we can write down 45 is equal to 5 plus 16 minus 1 into d. Now in this equation the only unknown is the common difference d. We can find that out by simplification. We will get d is equal to 45 minus 5 by 15, which is equal to 8 by 3. So the common difference for this arithmetic progression becomes equal to 8 by 3. Let's take another example which will show us the use of sum formula in a different manner. This is example number 7 in the chapter Arithmetic Progression. The question reads, the sum of first n terms of an AP is 5n minus n square. Find the nth term of the AP. Now we can write this sum to n terms of an AP as Sn is equal to a plus d plus a plus 2d plus a plus 3d up till a plus n minus 2 into d plus a plus n minus 1 into d. So sum to n term of an AP will be equal to sum to n minus 1 terms plus the nth term. That is, Sn can be written as Sn is equal to Sn minus 1 plus An, which will give us An, that is nth term, is equal to Sn minus 1. Now in the given question we are told what is the sum to n terms of an arithmetic progression. Now we can easily find out what is Sn minus 1, that is sum to n minus 1 terms, by substituting n minus 1 in place of n. We will get Sn minus 1 is equal to 5 into n minus 1 minus n minus 1 whole square. So by using the expression that we derived earlier, An becomes equal to Sn minus 1. If we substitute the values of Sn and Sn minus 1 in this equation, we will get the nth term An to be equal to minus 2n plus 6, which is equal to minus 2 whole multiplied by n minus 3.